Today we are going to start looking at how you apply trigonometric ratios to non-right angled triangles. So this is not using SOHCAHTOA. The first thing we're going to look at is how you calculate the area of a triangle. And first of all, I want to show you where this formula comes from so you have a better understanding of why it works. So in my example here, we have a non-right angled triangle. Now we know normally that to calculate the area of a triangle, we do half base times height. In this example, I have noted that I have the base, but this dotted line here indicates that I don't in fact have the height, but I do have a means of calculating the height. By drawing in this height line, I have created a right angled triangle for myself, and I can apply SOHCAHTOA to work out the length of this height. So if I do that, SOHCAHTOA says this would be my hypotenuse, this would be my opposite, and this would be my adjacent. So what I have is that sine C is equal to the opposite over the hypotenuse. Now my hypotenuse is A and my opposite is the height. So if I rearrange this, I'm going to get that H is equal to side A times sine C. And it's using this piece of information here that I can rewrite this formula to involve trig. So the area of a triangle is going to be half times the base, which have been given, so times the base, times A sine C. So I'm going to rewrite that as half AB sine C. And that is the formula for how you calculate the area of a triangle when the height is unknown and you've been given an angle. So let's try and put this into practice. Okay, so the last formula was half AB sine C. We are going to adapt this formula because we are talking about P, Q, and R. So I'm going to say that my area is half PR sine Q. Okay, and so that I can get this properly matched up, here is angle P, so directly opposite it is side P. Here is angle Q, and you'll notice it's the angle we've been given, so this is side Q. This is angle R, and then directly opposite is side R. So when I go to do my substitution, I'm going to do a half times side P, which is 120, times side R, which is 140, times sine of 132 degrees. And when I put that into the calculator, I get 6,242.42, and then this is an area, and our units are meters, so it's square meters. Okay, let's try another example. This one has been unlabeled for us, so we can put in the labels ourselves. So I'm going to say that this is angle A, this is angle B, and this is angle C. So my formula again is going to be area equals half AB sine C. And if I go through that process again, this is side A, this is side B, and this is side C. So I'm going to have a half times 7 times 2 times sine of 130. And again, putting that all in the calculator, I'll get 5.36, and then the units this time are centimetres, and again we're working out area, so it's square centimetres. And then final example, a piece of plastic is cut out in the shape of an isosceles triangle. Calculate the area of this piece of plastic. Now, we should know that an isosceles triangle means that you have two sides that are equal, and clearly we can see that this side and this side are equal. So I'm going to label my triangle again, so I'm going to have A, B, C. So there's side A, there's side B, and there's side C. So I'm going to have the area equals half times 5.8 times 5.8 times sine 36 degrees. Okay, so half AB sine C, half times 5.8 times 5.8 times sine 36, and that's going to come out with 9.89 cubic centimetre, squared centimetres, sorry, not cubic centimetres, squared centimetres. It's really important to note that if you're doing one of these questions in the exam, you get a mark for identifying the correct formula. So make sure, like I did in the previous two questions, that you are indicating that you know that you are calculating the area of a triangle. And that formula is given on your formula sheet, so you do not need to remember it.